A warm welcome to all the viewers who have joined us today for our live stream. I'm very happy about your interest in the interview with KML-Vision founder and CEO, Dr. Philipp Kainz. The interview will start immediately after this short introduction. For those of you who have joined us via your YouTube account, there will be an opportunity to ask questions within the live chat function of this interview stream. Dr. Kainz will answer the questions in the chat. In addition, if you are interested in asking questions and you don't have a YouTube account, you can send your question to this email address shown here. The email address will also be shown in the top of the live stream window. If there are short glitches during the video transmission due to some internet problems, I would like to apologize to you already now. We do our best that at least the audio is functioning to 100%. I don't want to keep you in suspense any longer, and we will start with the interview after a short crossfade. Enjoy the conversation. Hello, Philipp. How are you today?
Hi, Stefan. I'm good. Thank you. How are you doing?
Wonderful. So once again, thank you very much for agreeing to give me this interview today. And I'm very happy that the day today worked out so well. And I appreciate that you took the time today, despite your busy schedule, to be in part of this interview here. Philipp, you are the managing director of KML-Vision. And congratulations, by the way, by winning the Born Global Championship Award last year. I'm really impressed about that. So your company is dedicated to the development of analysis tools for scientific research, which are machine learning algorithms that assist the scientists in pattern recognition and allow observation of morphological changes in, for example, cellular parameters. Can you tell us a little about how you got interested in this topic? What is your scientific background and how your company was founded?
Sure, thanks. It's my pleasure to be on the interview. Thanks for inviting me. It's always nice to talk a little bit about the background as well, other than just pitching a product. So there's always a lot more to a company than just the product and what's seen in marketing. And I think this is a nice opportunity to talk about this in more detail. So my background is in computer science. I studied at the Graz University of Applied Sciences e-health, which is kind of a mixture between medicine, IT, and economics. And from that, I advanced to the Medical University of Graz, where I did my PhD. And I was working mainly there on histology projects. And I was developing image analysis solutions based on machine learning and deep learning for solving large-scale, high-resolution imaging problems. And from that, my co-founder and I, we decided that these tools we have been developing in the scientific setting, they have so much potential to be used in practice. So we decided that from going from specialized solutions to a product that can be used by anyone, basically, will be the goal of a company. And so we decided to found KML-Vision.
Wonderful, exciting. So it's also, I think it's a very exciting field, the pattern recognition combined with artificial intelligence and machine learning. And this brings me to my first question. What makes your company KML-Vision so special when you somehow compare it with your competitors or other AI CROs on the market that are also looking for tools that support medical and pharmaceutical research?
Of course, I mean, the main driver for founding the company has been that we wanted to provide some accessible solutions to people who don't have the background to create such solutions on their own. And over the last couple of years, we have been developing a platform technology that allows us to solve a very diverse set of problems. And this involves any aspect of multidimensional bioimaging, basically. So from in vitro assays over to high-resolution multifluorescence imaging, the platform can cover basically anything. And others are kind of very focused on particular verticals, so for example, histopathology. And of course, in the biomedical, or when you want to do cutting-edge biomedical research, and probably you also know that best there are so many different processes and stakeholders involved that you probably need more than a single software solution. And we acknowledge, of course, that this is great variety and poses a challenge to the research process, and that this diverse set of research questions, they demand sustainable solutions. And of course, you could go ahead and develop AI tools for individual projects and that serve very specific purposes, and which actually this is where we come from, and we know that this is creating kind of ad hoc solutions. And these don't really scale. So for the next project, you need to repeat creating another tool, another model, and for the next another, and so forth. And now we have a platform solution which cuts down the time of developing these flexible AI-based solutions.
Mm-hmm. Are your customers also involved in the development of your product? And what does the cooperation with you look like?
So in general, we try to involve them very closely, and this makes us also quite approachable. So we have kind of a unique opportunity to involve the clients very early also in development of new products. And larger companies, they just don't have this flexibility anymore, and they are limited in adapting to individual needs. And as I was saying before, there are so many different things when you do research. In the end, there's always a big trial and error component involved. And if you want to achieve real innovations, you of course need the tools that let you work creatively rather than executing just repetitive tasks all the time, for which like humans aren't really good at anyways. So we try to involve the customers very early, and I think the main pillar of providing a good software solution is understanding the requirements. So at some point, the customer has some research question, and we try to challenge this. So perhaps also to give some feedback to the customer and say, hey, did you formulate the problem, the research problem, in the correct way so that we can help you with our tool set? And if that's not the case, we try to rephrase it in a way that our technology also is able to help in that.
And how do you ensure that the technical inquiries from a customer reach you promptly and are properly understood? Because sometimes there's, I would say, there are different languages between biological scientists and medicinal scientists and bioinformaticians.
I think we have a really good understanding of the how a lab workflow, for example, looks like, and how people expect to work with such a software. And this has been like the result of a very long research process on ourselves, or we did ourselves. And in the end, it's always about letting communication be the most important part of collaboration in that sense. So you can have the best tool, but if you don't understand what the clients want to solve with it, it's useless, basically, because they won't be able to use it. And we are trying to solve that or sort it out within the first couple of meetings we have with clients, and enable them to use this technology. Sometimes it's just involving some changes in the organization itself, maybe some changes to the process when there's more digitization involved of samples, for example. And with that, or armed with that knowledge, we enable people to use this technology.
How do you think, Philipp, the topic of customer experience and user experience will change the application of AI-driven software in the scientific environment and especially in medical research with regard to short-term and mid-term expectations?
So many organizations are still using, let's say, the standard way of analyzing images, or like using AI software is not that common. Even we are in 2022 right now, but there are some very rigid decision processes in place sometimes that prevent a faster establishment of new tools within organizations. Of course, that is owed to some part to the regulatory processes, and that you need to have a very strict and rigid core set of quality management, which is possible, of course, to break up and to include new innovations. But this is more, let's say, a matter of how willing is an organization, or how willing is a client to try that out in a specific setting. And the faster they will do some proof of concept implementations of this technology, the faster they will be able to use this in routine and in production. And I think that the customer experience and user experience, especially in the field where a lot of scientific work is done, needs to be separated in some way. So you cannot just go ahead and say, I build a software and these are my users, and I sell to the users. So that won't work, because there are so many different people involved. And when you think about how decisions are made, so when the software or a tool or technology gets evaluated within a company, it's always kind of bottom up and top down mixing, because you need to communicate the perhaps economic benefits to the decision makers, and the day-to-day benefits for routine work to the users. And this is, of course, definitely something that will expand and will get better in the future, because many companies have realized that there is no way of just selling off-the-shelf software, because the use cases are so diverse in this field.
What will happen to vendors if they do not focus on this issue, customer experience and user experience? What do you think about that?
I think that many of them, they are really already focusing on that. So that is a very nice movement we see on the market. So it's not just we go ahead and sell what we had or what we developed over the last 20 years, and we try to resell it in 2022 as well. So they are kind of adapting new technologies and new ways of thinking how people interact with software, because this has also changed a lot in the recent years. And since software is kind of ubiquitous, some people are kind of expecting that there is a software for any kind of purpose, but maybe there is not yet. And definitely the vendors need to adapt to certain needs that come from the market, and that they can kind of integrate into their existing products. And if they are not able to do that, I think that there will be a change of tools from, let's say, big enterprise on-prem solutions to cloud-based systems that are far more flexible, that they can also enable a lot better cost control when you invest in something like this as a company. So vendors that fail to do so probably will have a hard time doing some upsells or some other placing new products of the same business model.
Interesting. And what do you think are the challenges when you develop AI technology and you have the goal to achieve harmonized software with regard to user experience, but you have users of different levels of experience? What do you have to consider about that?
Yeah, that is an excellent question. Of course, there are a lot of tech-savvy people among biologists and medical doctors, which are our primary users. But there is, of course, a huge gap between what their previous experience with software is and what they expect from AI software it doesn't work wonders, of course, but at some point you need to understand what are the benefits of a software and how do you use it. And when you develop such an AI tool, you can't just assume that people know how the machine learning process works. So there is a lot of accompanying documentation we need to provide and also educate people on the new technology so that this is easy to use and it comprehensively carries the essentials of machine learning. Otherwise, it's still a black box no one wants to touch.
So you mentioned that software is constantly changing, especially when it is supported or when you have highly innovative applications you're using. How do you ensure the stringent interaction that is necessary with your customer during the developmental phase? And how do you ensure this during the subsequent review and operation of your applications? And how do you handle the situation when a customer afterwards requires a new feature and is by short notice, which can happen? I know this from my own experience.
Yeah. It's good that software is not something you built and then it's there. It is kind of a burden and an opportunity at the same time, because if you have some feature that doesn't really fulfill your requirements right now, but there is maybe just a small add-on or some change you would request because it just doesn't fit. Every vendor tries to build something that is not super customizable, because at some point you won't be able to maintain a lot of installations, for example. But the requirement that you need to adapt to certain special new features that are for let's say a small set of customers in a very particular field of application, that is easily done or can easily be implemented because it doesn't touch the entire software package. And we try to involve many of these stakeholders also when we develop a new feature that perhaps is driven by let's say 2 or 3 of our prospects or of our leads in the market. Then we involve them very early in the feature design process before we even start to implement something that may not be even fitting what they expect. So there is a design process where we have interviews, where we try to gather the expectations of the users, because at some point, if someone says, I want to have, I don't know, this cell type recognized, this is a very generic formulation. And we try to break it down into what is the essence and what is maybe also a synergy we can have with other features we are developing, so that we are quite efficient in delivering on a very timely basis new features to our software, where we can scale it immediately also to other of our clients. Because there are many good ideas out there, but it's just not possible to scram them every single one of them into the product. So there is a prioritization, of course, happening. And when a customer wants to have some add-on or some subsequent change of the software, short notice is relative, I would say. So if it's half a year, it's already short notice probably.
Okay.
So the idea is, if we can manage it and it's possible within the roadmap we have for our product, we can always squeeze in some smaller features that, for example, take 1 or 2 weeks of implementation. But I think that is also something that is really nicely possible with a company like ours, because we are flexible enough to adapt to these wishes.
Okay, yeah. Maybe this is also due because you're very, let's say, a company that its person is also interacting close to each other, I guess. Yeah.
Yes, definitely, and it's always the case because we are very R&D focused. So there are different kinds of companies on the market. We are not just a distributor of standard software. We are creating everything by ourselves. So it's something that organically grows into something that the market or to maximize the product market fit, basically.
Philipp, when you look back to the early times when you start your activities with your company, what were your 3 key learnings within the collaborations with your clients? Yeah, and when you compare this, what are the differences between clients from the scientific part of academia versus colleagues or scientists coming from pharmaceutical industry?
So the key learnings, I mean, one key learning definitely was people need a good user experience to be able to successfully work with software. We ourselves, we come from the algorithm development side originally, so we started out as like a 2-man service company, and we were developing individual software solutions, mostly focusing on the algorithm part. And then we made some basic user interface, which didn't have any graphics or visualization or anything. So it solved the problem, but not in the way the customer expected it.
Okay.
So the key learning was, I mean, we now have in our ICOSA platform a huge portion of our development dedicated to data management, which wasn't even the plan in the first place. So one of the key learnings was, okay, if people cannot really manage their data and understand in a very simple way the value of data for this kind of analysis, we will be lost. So we won't sell any single algorithm if that is not the case. And so we built the ICOSA portal, which basically is the interaction the user interface for interacting with the entire platform. And I don't think that there's too much difference between a client from academia and a client from the industry, because in the end it's science, and the good scientific practices and how you conduct science, it should be the same, right? So it's international, and it's also not really restricted to some branch of scientific work. But to add to that, I think it's really important that there is a lot of more cost and performance pressure in the industry than in the academic sector. And I mean, this is kind of the tension. Everyone is kind of working on the academic side. You need to apply for funding, and on the industry side, you need more projects and try to get revenue from that. But in both cases, our tools can really help to accelerate these workflows that are involved. And it doesn't matter if it's in an academic or an industry setting, because we are really focusing on speeding up and making the life easier for our users.
What one can say is that you are pioneers in the field of machine learning and development of deep learning tools for classical pathology especially. And therefore, the other question is, where did you also have to pay the classical apprenticeship money in the early days?
I wouldn't say that you ever stop paying this money. So
okay, cool.
it's kind of an ever evolving process. So if you say you're at the end of learning, you're probably making a huge mistake. So you never stop learning and investing, let's say, some money or some time as well into really, reaching out or reaching for the moon, basically, will kind of get you where you want to be, because in the end you want to be positioned like a leader in the field. You want to understand what your target customers are doing, and at some point you need to do a lot of advancements, and you need to do a lot of development before you even can show to some client, hey, this is working, if they never had heard anything about it. So I think one of the biggest challenges for a software company, or especially our company, was to convince people that this, what we are presenting and what we are talking about, is really working, and they want to lay their hands on it. And we were lucky, and we had a huge R&D funding over the last couple of years, which enabled us to create the tools in a way and kind of focused on the customer's needs, so that now we have a really good fit, so that people can actually start using it right away. And this is our goal.
Someone in the audience who is listening to us now, and he is interested in investing in AI tools, especially new ICOSA Plus, for instance. What are the requirements that he have to think about that have to be fulfilled when implementing such AI-powered image analysis?
So the first one I would suggest would be a thorough understanding of the research process, or the business process, basically, that needs to be supported with these tools, and then try to figure out what are the expectations. So do you want to have a very specific part of this process automated, for example, or do you want to have I don't know, more stakeholders using the same technology, bringing them together in a virtual space on the image data? Of course, there's something involved regarding the imaging hardware and data storage, because you need some basic IT infrastructure. You just can't say I'm going to use AI tools at the larger scale if you don't have the infrastructure for that. But luckily, I mean, many of the investments into such tools, or even earlier in large-scale storage, when automating the imaging has been like on the rise a couple of years ago, many people just invested into storage solutions. So they have petabyte scale storage in-house, but there's just the data sitting there, and most of it is just, it's just there, but it's unused. And so they have a certain prerequisite they already fulfill with data storage and imaging hardware. And what you never should neglect is the skill set of the personnel. So you need to have a basic understanding of what is it worth if I have my data digitally analyzed? What is it worth to have also to invest into human resources to build up the skills of understanding the results some of these tools deliver? Because in the end, it's just, if you really boil it down to the essence, it's numbers and numbers and numbers and numbers. And if you don't know what these numbers mean, for example, what is the sensitivity of an algorithm, then you won't be able to use this in any setting. And the attitude should be that you want to learn something new, and that you're curious enough to try it. So it's not something that you can touch. I mean, AI and software in the media, it's sometimes really hyped and seems intangible. But I hope that with our technology and with our products, we can kind of reduce the fear of getting in touch with such technology, and that it will be widely used throughout the industry.
In some, I've already asked and you answered that there are no differences between clients coming from the industry, pharmaceutical industry, or the academia. Nevertheless, do you somehow in the interaction with the scientists figure out some differences at all? May these relate to the differences that are more to the research topics the clients are working on, and or is this not the case?
No, you're right. So there is a little bit of difference because in academia you need to strive for the newest discoveries. So which is perhaps not the case in the industry, where you have more throughput and need to optimize, and the goal is a little bit different. But in the end, developing the tools that allow you, I don't know, using AI technology or image analysis technology for a wide set of use cases, this requirement is the same for both of them. But in general, there is perhaps also a little bit more, let's say, freedom in creativity in the academic sector, which you don't have, maybe, of course, also due to the revenue pressure companies have. That would be one difference I would be noticing. Yeah. But in general, one thing I would like to add was that, I mean, when you think about how to create like spaces or communities where people can exchange regarding these kind of technologies, it's driven by both of them. So there are companies that are very strongly interacting with universities, not only because some of the universities may have unique equipment that the company just rents out, and then of course the staff operating these machines is also rented out from the university to the company. So if you think about where do they meet, so where do they exchange regarding new technology? There are some forums, there are some conferences that are attended by both the academic and the industry sector. And as I said, in the end, they are scientists and they know how to talk to each other. So it doesn't matter where they come from, but it's definitely something where both find a space to exchange their experiences with such technology. And this would be also an interesting part where you can just place the right information for using such kind of tools. Because in the end, they want to understand how this works, and they want to be able to assess if they would benefit from it. And you can only do that if you facilitate the exchange and the communication between them.
Okay, yeah. But both have a common sense of how they look at science, yeah, you're right, yeah. Philipp, what do you think about the statement that the development of new machine learning concepts somehow feels like being part of improvisational theater or playing chess, free chess?
That is true. So there are a couple of things to unfold here. Of course, neural networks are the state of the art when it comes to image analysis, but there are two different philosophies we can kind of support with our technology. Not every algorithm we develop, maybe also in a custom project with a client, needs to be based on deep learning and neural networks. So we are able to choose the technology that fits the purpose the best. So we're not just a general applicant of deep learning to everything, because it certainly has some requirements on its own, let alone the amount of data you need to train a robust model. But in general, it's quite interesting to see that we managed to do the implementation and to bridge the gap between something like a very standardized way of working with software and the flexibility, or while actually retaining the flexibility to adapt to new use cases. So it's exciting that there are so many different things that are happening, and it never gets boring. So it's some kind of a fuel for our company to also facilitate innovations and let people try out new things. but just on a very or in a very accelerated way. So they don't have to invest like a month into an image analysis, then perhaps go back and repeat the protocol and I don't know, make new samples and stuff like this. So this iteration is happening much faster, and the idea is to let the customers work with this technology and in the end with neural networks the way they intend to.
And is this somehow one of the ways how one could increase the trust in new technology like artificial intelligence? Because sometimes I feel people are somehow reluctant to this new technology, or so they use it on a daily basis with their smartphones, smart cars, or whatever.
Yeah, that is interesting. We have been noticing that because at the end, when we talk to new clients and they say, "Oh, it's a nice and interesting technology, but how does it work? How can we benefit from that?" These are questions that in large portions they focus on. Okay, there's something new. I want to try it. I'm curious, but I'm kind of hesitant. So I think we are the only company that offers free trials for using and trying out this technology, and this makes it quite accessible on a very in a very easy way to people who want to just try it out. Because in the end, if you try something new, it's like learning to ride a bike. You need to try it, and at some point you will manage. And the idea is that we have some showcases, we have some prepared projects where everything is like explained in a way that you understand what is happening. But in some ways, people think of it like a black box, and they sometimes want to understand, and sometimes they don't need to understand what is happening inside. And the way of approaching such technology is kind of or to use this technology is interesting, because in the end you get in your car, you know how to drive it, but you don't know how the engine works, and you don't care, and you trust that it works because many other people have also been driving cars, right? So in that sense, it's pretty interesting to see that there's a barrier for this new technology, where for other cases, people are not really reluctant to use anything. But in general, if we talk about data, so the awareness of the value of data and how data adds to your business process is kind of it's interesting, because at some point you have in the end your results, and what you want is the result, and how you get there you don't really care if it's AI technology, if it's just calculator, or if you draw it by hand. It doesn't matter as long as you are at the end satisfied with the results. But AI and big data, these two concepts, they are kind of always a little bit scary, because everyone is talking about, oh, there's huge amounts of data no one can process. That is not true, because we have tools to process it. You just need to know what you want to have in the end. And for image analysis, it's particularly easy to communicate what the tool does, because you can visualize it. So people or humans, they are very good at understanding visual concepts. And if you create some experience where they understand, okay, here in that area, the algorithm made an error. And this error may be because we didn't put enough data into it, or we did some mislabeling in the data and stuff like this. And like with these small improvements, you build up trust, because the human is always involved in creating the AI. It's not something that you just get off the shelf and just press a button. Sometimes this is also okay, but if you want to really establish this technology, you probably need to be involved also in the creation of the tools.
Philipp, you have so many customer contacts, and so you're talking to so many different people. And so in your experience, what expectations exist regarding the performance of AI-assisted image analysis? And could you somehow look at, is the orientation, are the people interested in retrospective technology orientation, or do you think should this technology only be used in a prospective kind of manner?
So there is, one example we encountered recently was when we talked to them about, hey, we have technology that enables you to cut down the analysis time by, let's say, 97%. They were like, oh, that's interesting. Let's just try that out. We have a data set and we want to know how this performs compared to what we already did. And I think this is a very good example to evaluate this technology. So in a sense where also referring to your previous question, where you need to build up trust that it does something meaningful, you need to validate it. And not only if you're in a regulated environment, but just for the scientific purpose of using a new method, right? So you need to prove that it's working. And approaching that the new field or the new application with existing data and questions, this is really a good way to get started and get familiar with it. So in that sense, AI technology will be able to assist you in getting information out of existing data, but also lets you establish a very sustainable method for future projects. So you get a lot of value out of it if you have something that you can validate with and apply this knowledge, because in the end it's knowledge you integrate into your company and you build up IP, basically. That's not something that, you're not just using some standard tool like Microsoft Office, like everyone can use it, but you're building up IP, how to solve complex image analysis use cases with state-of-the-art technology. And if you integrate that into your processes, you will be gaining a competitive advantage over others who fail to do so.
Philipp, and I think this is the way how you also can convince people who are experienced in image analysis and already have stable algorithms in place, classical image analysis algorithm. And this is the way how they then can benefit from this image analysis algorithms that are based on machine learning processes.
Yeah, it definitely helps to convince them, because in the end, if you can show that you're, let's say, 20 times faster and you arrive at the same or even better and more stable results, that speaks for itself. You don't need to argue any longer.
And furthermore, you can get results that you would not realize that are in your samples when using classical algorithms, for instance.
Mm-hmm. It allows you to adapt much more to what you already have. So the idea is, when you do, for example, also, or if you have, let's say, you established AI technology and AI-based image analysis in your company, and you want to do a rerun, or let's say extract information you have already from already run projects. So there is a lot of information just sitting there, or data, until you make it to information. Data is sitting there, which can be retrospectively analyzed. So you increase the value of what you already had recorded in the past, and integrate and create new insights from already existing data. So machine learning also allows you to do this retrospective analysis, where you don't need to know everything beforehand. For example, how the variance in the image acquisition is, so they are more robust to outliers. You can work around certain artifacts that may occur during the acquisition. Everything that is kind of adding dirt to your data is easily solvable with machine learning or with deep learning. And the tools you have developed for a very specific use case, they probably cannot be easily transferred to a new one unless you have the exact same setup. And this lets you apply this technology in a much more versatile way.
Philipp, in your opinion, what are the most difficult issues to solve in order to provide the user with a machine learning tool that radically improves the original custom process while being very easy to access for the people in the lab?
Okay, so the idea is that it's substituting some existing method or some existing process that is working for them. And I know that once you have established some standard for analysis, or let's say some piece in your SOP, you can just execute. It's pretty convenient to stick to it. So the most difficult issue is probably not that you have something that, or you can get something that works, which technologically we can do, but to actually let this new method also enter an existing process and substitute something that is has been established. So it's at some point a matter of how ready are these people to make the change, and how easy can you show it to them that perhaps maybe in a parallel run, so you don't need to do blue-green deployment and say, okay, from today we do just the new way, which is rarely a good idea. So just letting it sink in and letting get people familiar with it. So I think a difficult issue to solve is also dedicating enough resources and time until this process and this technology gets established within the process.
So, Philipp, image analysis is a well-established technology that has been developing at an immense pace over the last 20 years. What are the opportunities in using AI compared to conventional image analysis?
So I think one of the main advantages of AI is adapting to new use cases. So this is just has become so easy to execute in a routine process that I think if someone in these years doesn't really consider implementing something like this, they will get left behind at some point, because you save so much resources if you have a platform or technology that lets you quickly adapt to new requirements, which is just not possible with conventional image analysis. So there are, like in our case, we have no code solutions. You don't need to script anything, and you don't need to have a special training. Even if the script engine or the workflow engine is really flexible, you need to train people, let's say for 1 or 2 months, actually to be productive with this kind of solution. I'm not saying that it's not possible, but you won't be able to evolve from this kind of manually driven analysis approaches. And perhaps it also doesn't really scale that well. So there's two aspects to the scalability issue, because of course you can just scale up some image analysis that is based on conventional image processing by clustering it or just dedicating more computing resources to it. But the second part is the scalability in terms of using it and providing it to an entire organization. So the idea to have one tool that can be used for, let's say, by one research group for a specific purpose that may be different from the purpose of another research group. And these opportunities, they can be easily and in the vast majority frequently be solved with AI rather than conventional image analysis.
And what is, in your opinion, or what are, in your opinion, the top 3 thinking patterns you have to bring with when you want to establish neural networks in a future-proof and a stable way for specialized applications?
So the first one would be to, be ready for a change. So in that sense that you that you allow a new technology to be established. So in the sense of, I mean, if you think about how you arrived at the current state of the art, you also did some research and did some comparisons, and then you selected probably the best one that's fitting to your needs. And back then, perhaps it was, okay, now I can automate stuff. But right now, it's I can automate and add some more flexible and intelligent behavior to my algorithms and to my applications. So understanding what the requirement is, so formulating the machine learning problem, I would call it, would be one thinking pattern you need to establish, because if you want to solve, let's say, a detection task, how many of cell type X and cell type Y are in my sample, then you probably need a different approach rather than having a segmentation of and generating morphological data. So this kind of understanding which type of model fits to which purpose is, I think, the most important thing you need to consider. I mean, if you're not knowing what you're looking for, it's always hard to get the answers. And in that sense, it's definitely a good advice to invest into learning the different types of training. So there are not many, but it will help you to better communicate also with the suppliers. So, for example, technology suppliers, if you need help, if they need to refine some models, for example. So there's always a different kind of interaction. And we also help our customers refine their models when they trained it, for example, to a certain extent themselves. But then there is always something we can apply, and we have a lot of experience over the last couple of years collected regarding the optimization of existing models. And you can easily get out the next 5 to 7 to 10% of performance just by applying some tweaks and train the model in a very specific way.
Is there a discipline, could be from research or any other discipline, for which image-based machine learning networks work most robustly, and for which application is this true in this discipline?
I think for image classification, there has been a lot of research from many industries because it's a lot driven by, let's say, the automotive industry, self-driving cars and stuff like this. But for the life science industry, I think it's also a little bit different because the research setting is a little bit different from, let's say, a routine setting where you just apply the same algorithm once it's validated over and over again. And if I think of pathology, for example, if you have a clinically validated algorithm that, for example, detects a Gleason grading in prostate cancer, this adds a lot of value. And the downside is for that you need a lot of data, of course. So I think there are different dimensions, and it depends on how you want to use this technology in order to say, okay, it has the best benefit. You cannot really say it has the best benefit in this or in that, but it's kind of subjective. If something is of value to you and it serves that purpose, then it's of benefit and it serves your benefit. So the technology kind of adapts to the processes you're trying to support with it.
So that the best benefit which would have been the next question, is more on a subjective kind of thinking or experience with AI, you would say?
Yeah, so I wouldn't dare to say that it has the best benefit in healthcare or the best benefit in automotive, because it's a technology, it's a tool, and it should be there to ease our lives and not just to be, let's say, the next prophecy we are chasing. But in general, the idea is that if you use the technology for its intended purpose, then you will get the best benefit you can get.
Philipp, you are experienced in using artificial intelligence, and many people are talking about AI, ML, deep ML, and somehow mixing these items. What is actually understood when one is talking about this so-called artificial intelligence that enables machine learning and deep learning? And what are the differences of these three terms? Maybe I think many people can benefit in this case from your explanations.
Mm-hmm. So artificial intelligence is kind of a scientific research field where you try to build algorithms that act in a way that you don't know whether you're interacting with a human or with a machine. And there has been a lot of philosophical questions also raised regarding what is artificial intelligence. Machine learning and deep learning are just methods you're using to create this impression of intelligent behavior. Essentially what it does, it's a statistical method that, or an adaptive learning algorithm that learns from a set of data to execute a certain task. And machine learning has been around for a couple of years now. It's not something new. And like machine learning is always or often associated with tabular data and finding patterns in large data lakes and data stores. But in general, it's also just a concept to for a machine to learn from data. And deep learning is kind of the next step or the next evolution of machine learning. It's actually a subset of methods that fit into the machine learning sector, which do one thing quite differently. So in machine learning, you need to extract the features, so the individual properties the model should focus on yourself. So there's always a feature extraction and feature design part involved, which is done manually. Whereas in deep learning, you have an end-to-end pipeline. So you just specify the input data and the output target. And the machine learning, or in that case, the deep learning algorithm figures out which features of your data are best suited to get to the target. And this enables you to remove this manual interaction with the machine learning process, which kind of course, introduces a bias. If you select the wrong features, you will never get to what you are expecting. But at the same time, if you use deep learning end-to-end pipelines, then there is the opportunity that the algorithm may select something that is not significant enough to really have a causal relation to what you're searching for. So these are kind of the perks and the opportunities for these three terms.
What do you think? Will AI associated applications, how will they change biological research in the coming years? Will they somehow be a driver and savior of the research, or are they more than, would one look at them more at the dangerous black box that can also drive you to false data interpretations and unsubstantiated decisions? What do you think?
That is highly dependent on how well educated the people are who use it. I mean, if you are just applying it naively, of course, that is dangerous and will lead you to dead ends. But I think it has a tremendous potential, and as soon as there will be, I mean, there's lots of education happening as well in the AI sector. So if you take a look at universities and other higher institutions, there are many courses that support you in the basic understanding of how to work with this kind of technology. And as I said previously, if you are not able to interpret the results that you get from it, it will always be dangerous, regardless if you use AI or not. But in this sense, I think that biological research is already benefiting, and not just from the image analysis perspective. There are in target discovery and in other areas, there are so many different applications of AI, also in predictive modeling, that allow you to be much more efficient and to do simulations on something that you previously needed to do in the wet lab.
We actually come to the end of our interview now. I have no more questions on my sketch sheet here. Thank you so much. It was fascinating and very interesting and very exciting. I really enjoyed the conversation with you.
My pleasure.
My pleasure too, and I wish you a pleasant day and a successful rest of the week.
Thank you, to you too.
Thanks so much. Goodbye.
Bye-bye.
Thank you, dear viewers, for your interest and for being with us so long. Thank you also for your exciting questions you have asked us. If we were not able to answer them during the live stream recording, we will send you some personal emails within the next few days. We will also post questions and answers with some excerpts from this interview stream at the website of CELLIMA in the next few days. You can find the internet address in the video, at the end of the video, and in the bottom of the information window of this live stream recording. Thank you again for being with us. Have a pleasant day or a pleasant evening from wherever you are watching. Take care. Goodbye.